Alright, today we're going to talk about using properties of parallelograms. Now again, you see the word parallel there, so we're talking about parallel lines in our polygon. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Both pairs. Okay? So we have the first theorem here, if quadrilateral is a parallelogram, then its opposite sides are congruent. Alright, so the definition is that both pairs of opposite sides are parallel. Because of that, because of it being a parallelogram, then both pairs of opposite sides are congruent. Okay? And in this case, segment QP is congruent to segment RS, segment QR is congruent to segment PS. Alright? Also, another thing, because it is a parallelogram, alright, if it's a parallelogram, if quadrilateral is a parallelogram, so because it's a parallelogram, what happens? Its opposite angles are congruent. So angle Q is congruent to angle S. Angle R is congruent to angle P. Alright, find the values of X and Y. Alright, if we look at our figure here, this is all we have. We're just told to find the values. We look at our figure here. We have these little triangles here on segment FJ and the triangle here on segment GH. That means those lines are parallel. And we have the two arrows here on segment FG and the two arrows here on segment JH. Those lines are parallel. So that tells us we have a parallelogram. Alright, because of that. Both pairs of opposite sides are parallel, we have a parallelogram. And then because it is a parallelogram, we know that both pairs of opposite sides are congruent. So segment FG is congruent to segment JH, which means the length of FG equals the length of JH. The length of FG is X plus 6. The length of JH is 13. Okay, you subtract 6 from both sides, X equals 7. Alright, so we found the value of X. Now find the value of Y. Well, because again, it is a parallelogram, okay, if it's a parallelogram, then both pairs of opposite sides are congruent. Alright, that supports that equation over here. And then over here, if it's a parallelogram, then both pairs of opposite angles are congruent. Alright, so angle F is congruent to angle H, which means the measure of angle F equals the measure of angle H. The measure of angle F is 68. The measure of angle H is Y, so Y equals 68. Alright. Now another theorem for our parallelogram. Again, if we have a parallelogram, alright, then its consecutive angles are, okay, consecutive angles. What does that mean? That means angle Q and angle P, those are consecutive angles. Or another example would be angle Q and angle R. Alright, those are consecutive angles. Or angle R and angle S, those are consecutive angles. Okay? And the last pair of consecutive angles are angle P and angle S. Alright, those are consecutive angles. So, what is true about these consecutive angles? Well, if you think back to, I think it's chapter 3 when we talk about parallel lines, alright, these lines are parallel because it's a parallelogram. Here's my transversal. Here's my transversal. These angles have what kind of angle pair relationship? Alright, and those angles are consecutive interior angles. And when we have parallel lines, consecutive interior angles are supplementary. Alright, so X plus Y equals 180 degrees. Alright, so opposite angles are congruent when you have a parallelogram. Consecutive angles are supplementary. Alright, so as shown, a gate contains several parallelograms. Alright, these accordion style gates. Alright, like we have down by our commons area. Find the measure of angle ADC, so that's this angle here. when the measure of angle DAB is 65 degrees. DAB is here, all right, and that is 65 degrees. Again, we have a parallelogram, all right, and these angles are they opposite or consecutive? Because if they're opposite angles, they're congruent. If they're consecutive, they're supplementary, all right, and these are consecutive angles. So the measure of angle A plus the measure of angle D must equal 180 degrees. The measure of angle A is 65 plus the measure of angle D equals 180. So subtract 65 from both sides. So the measure of angle D equals 115 degrees. And the measure of angle D is the same angle as angle ADC. Okay? Alright. Another theorem about parallelograms. If a quadrilateral is a parallelogram, then its diagonals, again, QS and PR, those are the diagonals, alright, bisect each other. And we've heard that term before, bisect. It means it divides it into two congruent parts. So segment QM is congruent to segment SM, and segment PM is congruent to segment RM. And they're not necessarily congruent to each other. So segment RM is not necessarily congruent to segment QM. Does not have to be. Okay? So segment QM is congruent to segment SM, and segment PM is congruent to segment RM. Alright, but they're not necessarily congruent this way. Okay? Alright. Now, use properties of a parallelogram. The diagonals of parallelogram STUV, so we know it's a parallelogram, we're told that, intersect at point W. Alright, they intersect at point W. Find the coordinates of point W. Okay? We're going to find those coordinates, and that's not like, oh, okay, I go over 1, 2, 3, looks like it's 3, and it's up 1, 2, maybe 2.5, 2.6. No, we want to know the exact coordinates of that point. Okay? So now, we know that we're talking about the diagonals, and we just know the diagonals bisect each other. So if they're going to bisect each other, what does that make point W then? Okay? If the diagonals, segment TV and segment SU, if they bisect each other, okay, that means point W is the midpoint. Point W is the midpoint. So how can we find the coordinates of the midpoint then? By using our midpoint formula. Okay? Alright, using our midpoint formula. And again, if you remember our midpoint formula, it's x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. Alright? And we want to find the coordinates of the midpoint, point W. And I'm going to use point S, because point S is 0, 0. And I love using zeros. Alright? And point U, which is at 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4, 5. So point U is at 6, 5. Alright, so we want to find the midpoint of that. Okay? Add our x's, so 0 plus 6 divided by 2. And this is going to be point W. Comma, add the y's, 0 plus 5 divided by 2. Alright, so point W is 0 plus 6 is 6 divided by 2. 0 plus 5 is 5 divided by 2. Point W is at 3, 5 halves, or 2.5. Alright, so now we know the exact coordinates of point W. Now, wasn't that a hoop? Here's our wonderful owl. Okay. Any questions with that? Please bring them to class and we will discuss those. Thanks a lot.